Hi, teacher.
Hi.
Sorry to interrupt you. Are you doing anything important right now?
Well, yeah, I was doing this research about bacteria, but go ahead.
Oh, well, thanks. So I have these doubts about the math homework. So there's some formulas that I don't understand, some definitions I don't get. So I would like to help.
It's okay. Go ahead. Sit down.
Thank you, teacher.
Well, what's it about?
Teacher, the first question is, what's the concept of compound interest?
Oh my god, this one is so easy. Is he really asking this? Come on, the compound interest. The concept of the compound interest is that you work out the interest for the first period, add it to the total, and then calculate the interest for the next period, and so on. Come on, it's so easy. Please tell me that the next question is not so dumb as this one.
Next question is the formula for this interest compound in times per year, and the definition of each variable of the formula.
Come on, this one is easy. They teach it to you in the first day of class. The formula is A equals P parentheses 1 plus R over N to the exponent of NT. Come on, the variables are so easy. P is principal amount, R is annual rate of interest, T is number of years the amount is disposed or borrowed for, and A is the amount of money accumulated after earned years, and N number of times the interest is compounded per year. Come on, please.
The concept of exponential growth and the properties.
Oh my god, really boy, really? The formula is very simple. A is equal to PE to the exponent of RT. Oh, come on, the variables are final amount, P, original amount, R, rate of interest per year, in T, time in years. Come on, it's like for kindergarten.
What's the model of exponential growth with relative growth rate, and explain each variable of the formula.
The model, so easy. N times T equals to N lower exponent 0 E exponent RT. Come on. And the variables are N times T equal a population at time T, and 0 is initial size of the population, and R is relative rate of growth, and as always T is time.
The concept of radioactive decay and half-life.
The concepts are really easy. Radioactive decay is the spontaneous breakdown of an atomic nucleus resulting in the release of energy and matter from the nucleus. And the radioactive half-life for a given radioisotope is a measure of the tendency of the nucleus to decay or disintegrate, and as such is based purely upon that probability.
Lastly, the formulas of the radioactive decay model and the half-life formula, and explain each variable.
Radioactive decay model, easy. M times T is equal to M subscribed 0 E exponent minus RH, and everything it's almost the same. Come on, MT is equal to the amount of the time is present, and M subscribed 0 is the amount at the beginning or the original amount. R is decay rate, and H time lapse. And half-life, it's A equals A subscribed 0 times a half exponential T over H. And each variable is A is equal to final amount, A subscribed 0 is initial amount, T is time, and H is half-life.
Thank you very much, teacher. I hope I get a good grade in this homework.
Please do. Please.
Oh, sorry, I feel bad. I don't know why, but... Oh my god, what is this?
Oh god. I don't know. It looks strange. You should go to the nurse. Oh my god! Someone called Dr. Oscar House!
Oh my god, someone called me?
What's happening with this poor guy? I guess, what's in here? It looks like a bacteria, but I have to see all the symptoms. Let me see. In here, well, it looks like the bacteria are growing every day, every hour, and I don't know how to stop it. So I have to get along with my team so I can see what can I do.
Okay, team, what do we know about this poor guy? Well, we know that he has a bacteria population growing all over his body, which is a colony, and we have discovered that it is growing at this formula. Like, we have like 500 E to the 0.45 T is equal to 15. So, which means that in here we're getting like the time, and in here we're gonna see how many bacteria we have at the end. Are you okay with me? Yeah, doctor, we understand.
Yeah, doctor, yes.
Well, so now we have to discover how many bacteria are at the beginning of his sickness. Okay, team, we know that with this formula, the result will give us how many bacteria he has on his own body.
Okay.
Okay, in here we can substitute T and give us a specific number of hours. So at the end, we'll know how many bacteria he has after a certain time has passed. Also with E, E is our base. Okay, so now I want you to answer to me. How many bacteria is he gonna have after 2, 3, 5, and 7 hours? So that's your job.
So okay, you heard the doctor. We need to do this, and quick. Okay, he gave us these simple steps. We just need to follow them. Okay, we already finished our results. I think we are correct. We just need to deliver them to Dr. Oski's house and see what he can do with them.
Working in here, so we know that at first the initial population of bacteria was 500. So now, team, we have to leave T as a variable. And why? Well, because if we leave T as a variable, we'll know, like, after a certain amount of bacteria, how many bacteria will be at a certain time. So now we have discovered that thanks to some of the apple's properties, we can save this poor little guy from all his bacteria growing around all his body.
Oh, what is this? It's delicious.
But doctor, how did you do it?
Well, it was very easy. You only have to follow a process with this simple flow chart.